Hello everyone, and welcome to yet another PTC Nordic Talks webinar, where we are honored today by having Aniruddha Kadea from Capgemini for a session on a hot topic about semantic data mesh, the missing link in your data platform. But first, a very quick introduction about myself. My name is Torbjörn Peterson. I'm the Alliance Manager for PTC in the Nordics, and we are having these webinars every week. Same time where we also invite customers and partners for some inspiration on digital transformation to see what is possible and how to make things happen. And all the past webinars have also been recorded and are to be found on the registration site. So the agenda for today is first a very quick overview of PTC by my colleague Carl from the customer success team, and then Annie will start by introducing himself, touch base on a few challenges in his topic, how to address these, and then explain some of the business outcomes. And at the end, we are also having a Q&A session, so please keep your questions to the end. So now over to you, Carl.
Thank you, Torbjörn. So PTC is an international software company with headquarters based in Boston. We are developing software mainly for manufacturing companies since 1985. We offer tools for the digital transformations, such as CAD for design, PLM for managing data, IoT for connecting products or manufacturing operation, and augmented reality for visualizing and interact with the digital thread. To you, Annie.
Yeah, thank you. And this is the topic for today. So I come from Capgemini's Insights and Data. So Capgemini is a global company with more than 300,000 employees everywhere. And this topic is the third part of a series we have been doing. So part one was where we were discussing knowledge graphs and the human way of understanding data better. Then we looked at knowledge graphs as the glue within the data mesh, which Arne presented on the May of the 10th. And then this is the third part in that series where we are looking at a pattern we call the semantic data mesh. And myself, I'm Aniruddha Kadea. I work as an architect in Insights and Data based in Stockholm. So to begin with the topic, this is a trend we are seeing. We are all familiar that now technology is ingrained in our lives. So every business is now a technology business, and the boundaries between business and technology, they are diffusing, and data is no longer a byproduct of business processes. So we are looking at ways in which we can leverage data to drive the business itself. But is that easy? Based on the survey that Capgemini Research did in 2021, where the outcome of that research was that from a business executive perspective, only 25% of the business executives surveyed were happy on the visibility on data assets. And a bit more were happy with access to insights, but then a lot were quite unhappy with the data quality. And the main reasons we see why this happens is because it's difficult to understand the data itself. And there are two key elements we see that hinder the trust in data, and that's explainability and understandability. And what do we mean by these terms? So understandability, you could think of it as something that conveys the intended meaning of data. So what does the data in this object mean? Or when we are looking at codes, what do these codes mean? So we need to understand that. We need to understand relationships between a given element with another data element. And if we get more context around the data, then we can also improve the understandability. And as a second side of the coin, we see that we also need to be able to explain how a particular data came into being, from where that data came. Is it a single master or multiple masters exist that produce this data? And what are the different kinds of business rules that led to a particular data record that we see? So both these twins, understandability and explainability, that's the key problem that we need to solve in order to really progress to be a data-driven organization. And we have seen a lot of data lake initiatives that that had started. The promise of the data lake pattern was to be able to answer any questions of the data. But the challenges with data discoverability, understandability, and explainability, those have continued to limit organizations to reach the state of data mastery. And it's common experience that you end up spending a lot of time in the data layer trying to get the relevant data for a given use case. But when we look at data, so what do we mean? Why do we need data? So there are a whole range of use cases, and it's not just retrospective reporting, but you need data to do machine learning analysis. You need data for exploratory data analysis. So if you look at it from, let's say, two views, like how much data do we need and how fresh data you need, you have a whole range of use cases that need to be enabled. And one use case that we look at increasingly is, apart from historical reporting, you also need to be able to work with wide and shallow data, where the depth of data is shallow, but then you need to see a synoptic view of a particular instance of an object. And that's where we started thinking in terms of two views of data, which we refer to as a continuum and quantum. Now, these are dictionary meanings. So a continuum is something that changes in character gradually or in very slight stages. But then there wasn't a really good quantum definition from a data perspective, but this is how it is described from a physics perspective. It's a discrete quantity of energy. But when it comes to data, we can think of quantum as a set of data points or a enclosed data set. And that's where the different perspectives really help understand. And we've been very comfortable dealing with quantized data sets with our past dimensional models and data warehouses. Those were all quantization of data. But the continuum is something we haven't really thought about in detail. And then the question comes, how does the continuum come into being? And if we look at the way we go through different phases when you either define a product or a business service. You begin on the business side with defining requirements, and you get a market need that uh, starts the design phase of a particular product. And then during the design phase, you end up with specifications on the particular product, and then it moves towards the produce phase. And as the product moves through these different phases of produce, delivery, purchase, and then finally reaching the consumers, in the consume phase, a lot of business metadata is created, or it's accreted on the particular product. And in addition to that, you also have external authorities or external data that is fed into this whole cycle. And after it reaches the consumers, there's also a post-consume phase, and that again contributes to business metadata. And all this metadata is then collected in currently in a central data lake, but then it misses the envelope of metadata and knowledge graphs. So that's the key layers that are needed to help understand this whole data continuum. And it's also important that to understand that now we are going to live in a state of ecosystem. So the data that is accumulated also needs to be shared with partners, uh, and then we also have external triggers like the EU data spaces, and which promote collaboration based on data exchanges. And once this data lands in this sort of central data platform or data lake, however you may want to term it, it is then used to gather insights and data based on that, and it's used to both improve the current business processes, operational processes, so it feeds back into this whole cycle, but then it also feeds into the business need and helps define new business services or products. So this whole continuum you can then see in the three views of data. So when you look at the systems of records and you look at how data is structured in the origin, it's modeled in a different way. And the purpose of that layer is to enforce quality, deduplication, and transactional concurrency. But then the continuum is where you have this entire connectivity of data being expressed in a lucid way, and that's where graph technology really comes into picture. And on top of that, then you have the quantum view of data, and that is something we have been very familiar with. So how would a continuum look like? So this is just a hypothetical view of a particular instance of a sofa, the luxury sofa, and then that is then seen as a type of a luxury sofa class, and then it is then linked to design specs. But then from a continuum, you also have, let's say, supply chains that supply various components of this sofa. But then you also have the linkage to the factory and the assembly line where it is assembled. But on the consumer side, then this particular sofa is then purchased by a consumer, here Maria Swenson as a representative consumer, and then it's shipped using some delivery partners, and then you also have payments. So if you want to get a view, synoptic view on, let's say, luxurious sofa, this instance, and you want to see how was this sofa constructed, where did the components come from, to whom was it sold, how was it delivered. It's very difficult to get this kind of picture from the quantum view. And that's where the continuum view really helps. And the beauty of the continuum view is that you can change the focus of origin from either an instance of the sofa, or you could then have the consumer at the center and see the digital footprint of that consumer with your business. Or it could be a factory at the center, and then you could see that, okay, what are the different products that were created on in the relation to a factory, or which came from the factory. So it's very easy to change the focus area in your continuum based on the information needs. So what are the main enablers? Because we have been looking at two trends. One is this emerging interest in knowledge graphs, but at the same time, we're also seeing data mesh being quite actively discussed, and the whole thinking around data as a product. And we look at for the semantic data mesh, we see these three kind of trends that are really important in driving this architectural pattern. And that one is the data product thinking, which is how data will be delivered in future. And then for the continuum, a key element is graph expressivity, which improves on the understandability and explainability of data. And then also looking at a more software construction way or a data construction way, how will we package these data products? And that's where the whole microservices approach is will influence architectures. So based on all these considerations, what we have been building is a architectural blueprint, which we informally term as a semantic data mesh, because it combines thinking both from a knowledge graph perspective, but also influenced by the data mesh thinking. And it relies on enterprise knowledge graphs and graph technologies. So that is sort of the key element in improving the explainability and understandability of data. And increasingly, we see the graph data models, they will be indispensable to enterprises. And they also then lay the foundation to future ambitions to build digital twins, enterprise digital twins, and also we enable business analysts to answer difficult queries that require connections to large number of entities. So conceptually, we look at the whole semantic data mesh pattern as having different planes. So you have a data ingestion plane, wherein the concern of that plane is to be efficient at data acquisition from source systems. Then you have distributed transformation engines in this architecture, which help in cleaning and preparing data in order to populate both the data continuums as well as also build data products in the quantization layer at the top. And then you have different services that enable users to both query the data, but also enable data product teams in their whole data product construction process. So you have visual graph exploratory analysis for business users. You also have uh, data product stores and registries in this conceptual architecture, and that is aligned with the whole data mesh thinking. And then having data product catalogs where users can subscribe to it and also have query engines to interrogate the data for different use cases, whether it's building a report or building a dashboard or just doing an exploratory analysis uh, inquiry into data. And so what I would like to leave you here, and I would like to have more time for discussion. I think that's this is going to be a bit of a collaborative effort. So uh, the key takeaways I would like to leave you with in this talk is that we need to start thinking in terms of both continuum and quantum views of data. That's very important because both are needed. And currently, when we are only focusing on the quantum views of data, we are not able to address many important questions that get solved with continuum. In addition to the semantic, the graph layer in the graph continuum, you also need metagraphs, again, where graph technology helps in helping understand how the different data products are connected to each other and provide meaning around them. And then, as I mentioned, the semantic data mesh pattern, it requires co-innovation because each organization is unique in terms of its structure and processes. So this is a problem that needs to be solved together. And it's not a technology problem, neither is it solely an organization problem, but it's a multifaceted problem that involves organizational thinking, it involves information architecture thinking, and it also involves an IT technology thinking. So the problem needs to be solved at multiple layers. And last but not the least, um, knowledge graphs should really be considered as a key component of a robust data platform. So something that will enable this data continuum layer. So I would then sort of like to open the sort of floor to discussions. So
Thanks a
if
lot,
there are
Annie.
any questions, please.
Yeah, thanks a lot, Annie, for sharing a lot of interesting findings here on this very exciting topic. And your presentation actually demonstrates also on a very high level what is possible by using PTC software, like I mean the ThingWorks platform to make the digital thread possible. So I think, I mean, as I said, I mean, now over to the Q&A session. So, I mean, please go ahead and ask any questions you might have. Who would like to go first? So I could go first, at least, I mean, to kick things off here. So, Annie, I mean, what about, I mean, your recommendations on how to get started with a semantic data mesh approach? What people should get involved? What kind of, I mean, skill set should they have? What do you think? What's your recommendation?
Yeah, I think that's a really good point because how do we begin the journey is a common question that we get. And the main challenge comes is that we are when we speak to different stakeholders, the topic of knowledge graphs and ontologies, it's really something totally new for many IT organizations. So it becomes an exercise initially to help them understand the value that knowledge graphs bring and how it helps in improving the explainability. But the way we are approaching is to take a co-innovation, co-creation approach and then begin with small steps in providing value proof points of the approach, and that is a good start. So begin small, establish the value proof points, and then look at launching a larger scale out initiative. But the important part here is that this approach is augmenting the current data lakehouse initiatives. So it's not totally different architecture which advocates that, hey, drop everything that you were doing earlier. No, that's not how it is. It's basically enhancing the current approach and introducing the continuum layer in the architecture.
Thank you, Annie.
I have a question, if I may.
Please go ahead.
Yeah, actually, this could be two questions. The first, I think, thanks for this very interesting presentation. And this is also very hot topic. I just wonder, and also very big topic, actually. I just wonder specifically to the manufacturing or engineering space where PTC is focusing on, what is the current status and mostly used tool for this knowledge graph? I can see that from AWS, there's Neptune, from Microsoft Azure, they have digital twin graph, etc. So I want to understand what is the current status and the best tools. The second question is rather to the PTC team, as Torbjörn, you just mentioned. This is linked to digital thread, digital twin, PTC offering, ThemeWorks, and Windchill, etc. I just wonder specifically to the knowledge graph, this part, what tool PTC offers specifically on knowledge graph. So two questions or three questions. Thanks.
Should you get started, Annie, maybe, or I mean, and I can.
Yeah, I think from a tooling perspective, depending on which cloud provider you are on, there are multiple offerings, and you mentioned one of them, of course, Neptune on Amazon, but then also Neo4j with its Aura offering on Google Cloud that exists. So, and then you have Tiger Graph, you have D Graph. So there are plenty of choices out there. But I think the key thing is to start examining knowledge graph as an information architecture. So that also requires a lot of reorientation in thinking. So moving away from dimensional models or data vaults, and then start thinking in terms of nodes, links, edges, and a different information architecture. But then over to you, Torbjörn, on the PTC perspective on where you are with knowledge graphs.
Yeah, maybe, I mean, would you like me to answer that question, Carl, or?
I guess you were going to say so, but yeah, I don't have enough expertise in the field. So I think this is a question we can take in and answer to you later. I think it's Mr. Zhang who asked the questions. If you give us your email on the chat, and we will take this conversation later if you're okay with that.
Yeah, and overall also, I mean, I think, I mean, linked to the conversation and the topic here, I think, I mean, as I said a little bit also earlier, the ThingWorks, I mean, DPM platform might be, I mean, something that is, I mean, related to, I mean, what we are actually offering in this specific area as well. So let's dig a little bit deeper on that for sure, definitely. Any other questions?
I think there's a question in the chat from Anders. Would you like to speak up, or we read the question for you, Anders?
No, I can speak up. I am thinking about how this is sort of visualized for the users, and how that plays with other systems in the IT landscape, and how if CAP develop your own platform or UI for this to present this sort of knowledge, information, getting data from so many sources, and have this continuum of information. So that was my question.
Good question.
Yeah. So typically we are looking at, let's say, if I go back to the conceptual architecture in terms of capabilities that are needed. So the way users will interact with the data continuum graph is with a service that enables a graph discovery app, and there are many visual interfaces or visual solutions available in the market that allows a very intuitive analysis and a more point and click experience where you could also have at a click of a button different graph algorithms implemented, including community detection or shortest path and those kind of graph analytics engines. But then you could also have a query interface, so that would require an advanced user to be able to code in a SQL-like code. For example, if you are working with Neo4j, then it becomes Cypher, but then other platforms have different query languages. So that would be the interface for data continuum graph. When you want to consume data products, yes, that's something that will need to be constructed. A web interface that allows people to explore data products, request access to data products, and then also in the whole data mesh thinking, you also need to enforce that people have access only to the data that they can view. So that is also an important part of the way data products will be consumed by end users.
And the protection in the cyber world we are living in, I guess in the cloud, you need to have that access control as well for pushing, publishing the right data.
That's the elephant in the room, I would say.
Yeah, I assume that. Thanks.
Yeah, good one. I have one also question here. Maybe I will expose my lack of knowledge here, but what is the difference between data mesh, data lake, and data fabric?
So when it comes to data mesh is both an architectural construct. So it advocates a set of principles on how to build data products and what are contained in them. But it also has an organizational aspect where you really need to change or make changes or adjustments in the organization. So you have identified data product owners who understand the digital footprint around a certain domain. And then it also advocates a decentralized way of constructing these data products. So you have a role for IT, which constructs the self-serve platform, but then the data products are constructed by the teams that really understand a particular domain. So if you have a range of capabilities in your organization, then the team that is responsible for a certain capability or sub capability, they are the ones who are building the data products with support. It's a collaboration between business and IT in that sense. The data fabric takes a very architectural technological view, and that's where I think the whole aspect of wide and shallow data that is also being advocated. So knowledge graphs plays a big role in the construction of the data fabric. Data lakes and lake houses, they have been patterns on incremental enrichment of data. So the data lake really had a different value proposition that you could land all data in a common store, and then you could then create value based on that common data lake. But that hasn't really worked out because of the reasons we explained earlier around people being unable to understand how to understand the data, how it connected to other data objects. So the value was very difficult to realize based on the approaches in the data lake pattern and schema on demand, for example. So I think the lakehouse is one of the patterns that can feed into the semantic data mesh architecture, but they solve different problems.
Right. Thanks, Annie. Good explanation. Any last question from you in the audience? I had one actually, otherwise, and that is about, what do you think, is the overall, maturity of, organizations using, the data mesh methods in the market?
I think today what I've been seeing is a lot of interest and curiosity around what is the data mesh and how to go about it. So sorry, we are in the early stages around data mesh thinking, but it has really been grabbing a lot of interest. But one thing that the data mesh doesn't really solve the problem is the continuum problem. And that's where I see that combining these two approaches, sort of looking at the data continuum along with the data mesh thinking, I think that is going to help organizations have a really strong, robust data platform for multiple use cases in the future.
Thanks a lot, Annie. Guys, time is unfortunately running out, so many thanks everyone for joining, and of course a special thanks to you, Annie, for sharing a lot of great information here. And also stay tuned for the next Nordic Talks in 2 weeks about driving and measuring sustainability with digital thread by Accenture. So with that, I wish you a fantastic weekend. And if you might have any other questions, please stay and ask them on the chat with Annie. So bye everyone. See you next time.